Hello and welcome to Math with Mrs. Becker. Today in College Algebra, we are going to review for the Chapter 7 test. You will find in Google Classroom a blank copy of the Chapter 7 test review, as well as a filled-in copy like you're seeing here. I do realize that sometimes it's a lot easier to review when somebody's explaining step by step how to go through each problem, so that's what this video will do. We will start with number 1, and I will go ahead and walk you through each problem step by step just to make sure you really understand, okay? So number 1, it says to solve this system by the method of substitution. Now substitution, remember the rule states that you must have one variable by itself. It does not matter if it's x or y, but you need one equation to have either x equals or y equals. So if I'm looking at number 1, the easiest variable to isolate would be x, because all I'd have to do is add the y over here. I don't have to multiply or divide by anything. So I can easily say, well, x equals, the y was negative on this side. If I add it to this side, then it's positive plus 6. So now I would no longer use this equation. I would move forward with the problem stating that x is equal to y plus 6. Now the reason why it's called the substitution method, once you know the value of one of the variables, you substitute it into the other equation. So now I come over here and everything will stay the same except for the x. So 3x we're going to substitute plus 5y stays equals 2. Well, instead of x, I substitute in what x is equal to. X is equal to y plus 6. Now what we have is a multi-step equation. So I can go ahead and distribute the 3 to cancel parentheses. 3 times y is 3y. 3 times 6 is 18 plus 5y equals 2. Here I would go ahead and combine like terms. 3y plus 5y makes 8y. I still have the 18. It equals 2. Now here, to get rid of a plus 18, I go ahead and minus 18. What you do to one side, you always do to the other. 8y remains on this side. 2 minus 18 is a negative 16. If I divide both sides by 8, negative divided by a positive is a negative. 16 divided by 8 is 2. So y has a value of negative 2. But what you're doing is you're figuring out your solution, your ordered pair. Where would these two graphs cross? So to find that, now I substitute again. I want to find out what x is, so I take the y value and I substitute it into that equation where y is. X equals y, which we just found to be negative 2 plus 6. X is negative 2 plus 6, so that's a 4. So my solution, the ordered pair where these two equations would cross on a coordinate plane, is positive 4, negative 2. Now, one way to always go ahead and check your work if it's linear is, well, I guess linear and nonlinear. If we have a 2 by 2 system, you can always check it on Desmos. So when I'm going to Desmos, what you want to do is graph the original. So x minus y equals 6. Next, 3x plus 5y equals 2. So if I go ahead and graph those, I can see that point of intersection. When I tap on that point, I have 4, negative 2. We stated that the solution should be 4, negative 2, so we are done with number 1. Okay, next one. Number 2, the directions say again, solve by substitution. So you guys, it's the same rule as the last equation. The last system. You need either x equals or y equals. You cannot do x squared or y squared. When you're doing substitution, you have to have a single variable. So it's going to have to be from the first equation. You need either x equals or y equals. This time, y is going to be easier to isolate. I can take this negative 2x and add it to the other side. So here I would have y equals negative 2x. If I bring it to the other side, it's a positive 2x minus 5. So I will no longer use this equation, because if I'm doing substitution, I need an equation with the variable by itself. That's what I have here. Now you substitute that into the other equation. So I would have x squared plus, we're substituting in y squared, it has to equal 25. Well, instead of y, I have 2x minus 5. Now, order of operations, I would have to get rid of this power of 2. What I need to realize is that means that I have this binomial 2 times. So I can multiply this out. 2x times 2x is 4x squared. 2x times negative 5 is negative 10x. Negative 5 times 2x is negative 10x. Negative 5 times negative 5 is a positive 25. So I still have this x squared that was out front. Plus, combine your like terms here. So I would have 4x squared, negative 10x and negative 10x makes negative 20x, plus 25. I need to realize that this whole thing is still equal to 25. Okay, so what I did again, just to kind of recap, I got y by itself here. I substituted that into this equation where the y was. Because it's a binomial with a power of 2, it means I had that group twice. I FOILed that out, first outside, inside, last. Then I combined my like terms. I still had the x squared, I still had the equals 25. I just combined the like terms and I have it to here. Now what I want to do, I do realize that I have a power of 2. So that means I'm going to have 2 solutions. I need this thing set equal to 0. So step 1, I'm going to combine my like terms. 1x squared and 4x squared makes 5x squared. This is still a negative 20x. Now, I want this thing equal to 0, so I can either use the quadratic formula or factor. Well, if I minus 25 to each side, that cancels, but so does that. So I end up with 5x squared from my 1x squared and my 4x squared, negative 20x, I minus that to the other side. So now to factor, I'm going to divide out what they have in common. Both of these terms are divisible by 5, and they both have an x. So if I divide by the 5, it's on the outside. If I have 2 x's, I take one out, I'm down to 1. Minus 20 divided by 5 is 4. I have an x, I take it out, it's gone. Now when you are solving something that's in factored form, remember you take each piece separately, set it equal to 0. So on the outside, that's one piece, 5x equals 0. On the inside, x minus 4, set that equal to 0. Here, if I divide by 0, 0 divided by 5 is 0. Here, if I add 4, 0 plus 4 is 4. So I have 2 ordered pairs. One where the x value is 0, one where the x value is 4. Now to find the y value, we go to the equation that says y equals. Well, y equals, if x is a 0, 2 times 0 minus 5. So that would be the y value. 2 times 0 is 0. 0 minus 5 is negative 5. So when I replace x with a 0, my y value ends up being a negative 5. Now if I do a 4, y equals 2 times 4 minus 5. Well, 2 times 4 is 8. 8 minus 5 is 3. So there are the 2 ordered pairs. Now again, what we can do is go ahead and graph in Desmos and check our solutions. So if I go back to the original, negative 2x plus y equals negative 5. There's my first equation. X squared plus y squared, that's a circle, equals 25. Now notice I do have 2 intersection points. My intersecting points are at 0, negative 5. That's what we had here. 4, 3. That's also what we had. So there are 2 examples of the substitution method. One was with linear, meaning both of the equations formed a line. This one is nonlinear because one of the equations was not of a line. It was that of a circle. Now, number 3. This is elimination. Now, elimination is different from substitution. The goal here is to be able to add the 2 equations together and be able to completely eliminate a variable. If I add them right now, 5x and 2x, that makes 7x. That would not be eliminated. 3y and a negative 4y would be a negative 1y. Again, not eliminated. So what we need to do is multiply the entire top or the entire bottom by the same value so that way I can eliminate. If I want to eliminate the y's, okay, I already have a positive and I already have a negative. I can turn both 3 and 4 into 12. So to do that, I need to multiply the whole top row by 4 and the whole bottom row by 3. Now when you're multiplying, make sure that it goes to every value. 4 times 5x is 20x. 4 times 3y is 12y. 4 times 9 is 36. Now the bottom, I'm multiplying everything by 3. Every single term needs to be multiplied by that 3. 3 times 2x is 6x. 3 times negative 4y is negative 12y. 3 times 14 is 42. Now when I add them together, notice that the y's are eliminated because I have positive 12y, negative 12y. 20x plus 6x makes 26x. 36 plus 42 makes 78. To divide, or go ahead to solve for x, I divide each side by 26. 78 divided by 26 is 3. So now I know x. The goal here is to do the same thing as we did in the previous two examples. What we want to do is find if you graph these two, where would they cross? So I do need an ordered pair. Once you know one variable, you pick one of the original two equations and substitute that value in. Okay, it does not matter which one you select. I'm going to do the top. So 5x is a 3 plus 3 times y equals 9. Well, 5 times 3, that's 15, plus 3y equals 9. If I minus 15 to each side, positive 9 minus 15 is a negative 6. Divide both sides by 3. Negative divided by a positive, remember that's a negative. 6 divided by 3 is 2. So my ordered pair is 3, negative 2. Again, this is a problem that you can easily check. Make sure that you're correct. We'll just go back to Desmos and see if that's where those two lines cross. So 5x plus 3y equals 9. There's one line. 2x minus 4y equals 14. I do see one intersection point. Go ahead and check it. It says that we should have found our intersection point to be positive 3, negative 2. That's what we got, so we're good to go. Okay, now when we look at number 4 on this review, this is a problem that you really need to make sure you understand if you are ever planning on going into business, okay? So it says a small software company, they invest $16,000 to produce a software package. So what that is, that's called an initial cost. That's the money you have to put up front to just start this business, okay? You're gonna make a software package that sells for $55.95. So every single time you sell one, that's how much you'd bring in. Each unit can be produced for $35.45. So that's how much it costs each one, okay? So you're paying this much to produce it, you're selling it for this much, but the hiccup here is that there is that initial cost. So if you are trying to write a cost function, okay, how much do things cost? You have to remember the initial. It was $16,000 just to get the original equipment. Plus, every single time you make a software package, it's another $35.45. This is called a variable cost because it's for each unit. Your revenue, how much money are you collecting? Well, you are collecting whatever the cost is for your buyers, for however much you sell it for, okay? That's your selling price. So your revenue is $55.95 per software package. So revenue is the money you're collecting, okay? It's the selling price, how much are you selling it for, times however many you sell. Your cost is how much did it cost you to get started, plus how much does each individual item cost. Now, one thing that's really important that you understand is how to figure out what's called your break-even point. Your break-even point, that is the amount of software packages you would have to sell in order to not make any money or not lose any money. Your break-even point, to find it, you take the cost and you set it equal to the revenue, and then you would solve for X, which is the number of items you would need to sell. So I'd have 16,000 plus 3545X. There's your cost. We want to know when it equals the money that we bring in. So that is the revenue. Step 1, I need to go ahead and collect my X's onto just one side of the equation. So in order to do that, I am subtracting my 3545X. I would have 16,000 remaining. If I take 55.95 and I minus 35.45, I would have 20.5. Again, we're talking about money, so I'm going to go ahead and put $20.50. That's my x. To solve for x, I need to divide both sides by 2050. So if I go ahead and take 16,000, I divide by 20.5. This is the amount, this is what we get, okay? So if I only sell 780, I would not have made that money back. Now your break-even point, you want to know how much so you're no longer in the hole. So we would have to round up to the next software package. So it's approximately 781 packages at 780.5. That's the exact break-even point, but you cannot sell half of a package. So if you only sell the 780, you're still in the hole a little bit. When you sell the 781, you got yourself out of the hole and you actually made a little bit of money. Okay, there is the first page of the review. Okay, let's go ahead to number 5. Now, number 5 was when we were still working with systems of equations, meaning we did not transfer anything to matrices. What they wanted us to do is take a system and write it into what's called row echelon form. Now, row echelon form allows you to have an x, y, and a z on the top, a y, z on the bottom, or sorry, a y, z in the middle, and just a z on the bottom. So again, it has to be x, y, z, z. Another rule is that your leading coefficients have to be a 1. Okay, so when you go ahead and you convert this 3 by 3 into a 3 by 3 in row echelon form, you have to include what is called a map. So you are saying what you are doing step by step along the way to get this row echelon system, okay? Now, one thing you are allowed to do is interchange rows. Now, here I would not do that because I do have x, y, and z on the top, and my leading coefficient is a 1. So I can use this top row, but I don't want to change it at all. It's already in the format that I want. I cannot have x's in the second or third row. So I'm going to use the top row right away to get rid of these x's. So if I take negative 2 times row 1, this would become a negative 2x. If I add it to row 2, I would get a 0. I want that 0 in row 2. So this is where it gets a little tedious. You are rewriting everything except for the one row that you're changing. So the top row, x minus 4y minus z equals 3, that stays. The bottom, 3x minus 3y plus 2z equals negative 1. Now I'm getting a new row 2 by following these steps. Take the top times negative 2, negative 2x plus 8y plus 2z equals negative 6. If I add it to row 2, that is going to be my new row 2. Negative 2x, positive 2x, that cancels. That's why we did this step. You cannot have an x in that second row. 8y plus a negative 5y, well, that makes 3y. 2z plus 1z makes 3z. Negative 6 plus 0 is negative 6. Now here I can see that I do have just x's and y's here, which is what I want for row 2, but this needs to be a leading coefficient of 1. Since all of these values are divisible by 3, I'm going to go ahead and take care of that now. If I go 1/3 times row 2 to get a new row 2, my top 2 rows should be ready to go. X minus 4y minus z equals 3, that stays. 3x minus 3y plus 2z equals negative 1, that stays. Now to get my new second row, I'm going to divide everything by 3. 3 divided by 3, that would be just a 1y. 3z divided by 3, that's just 1z. Negative 6 divided by 3 is a negative 2. So now at this point, the top row and the middle row are ready to go. Now I just need to focus on the bottom. The bottom's only allowed to have a z. We want to go left to right just because I feel like it's the easier approach to this. So if I want to cancel the x, I'm going to take negative 3 times the first row because I would have a negative 3 here. Then if I add it to 3, I would get a 0. So my map, I'm taking negative 3 times row 1. I am adding it to row 3. When that happens, I'll get a 0 in the x location. I want that 0 in row 3. So I'm keeping the top. x minus 4y minus z equals 3. I'm keeping the bottom, the middle. Y plus z equals negative 2. I'm changing the bottom. To do that, top times negative 3. Negative 3x plus 12y plus 3z equals negative 9. Keep the bottom the same. 3x minus 3y plus 2z equals negative 1. When I add those together, that becomes my new row 3. Negative 3x, positive 3x, that cancels. 12y minus 3y, well, that's 9y. 3z plus 2z, that's 5z. Negative 9 and a negative 1 is negative 10. Now, on the bottom, I'm only allowed a z. So I need to cancel this y. Okay, right now it's 9y. So if I go ahead as a fourth step, if I multiply the second row by negative 9, then I could add it to this 9 and I'd get a 0. So I'm taking negative 9 times the row 2. If I add it to row 3, I'll cancel a y. I want that canceled y to end up in row 3. So again, I'm leaving the top 2 rows exactly how they are. Now I'm creating a new row 3. Take the middle row, everything times negative 9. I'm taking it times negative 9. Negative 9 times y is negative 9y. Negative 9 times z is negative 9z. Negative 9 times negative 2 is a positive 18. If I add it to the current row 3, I'm getting my new row 3. Negative 9y, positive 9y cancels. Negative 9z plus 5z is negative 4z. 18 combined with a negative 10 is 8. Last step. And then I have what's called row echelon form. I need a 1 here. So for my fifth step, I'm going to take negative 1/4 of row 3. That will be my new row 3. And that will be my row echelon matrix. The top, x minus 4y minus z equals 3. The middle, y plus z equals negative 2. If I take negative 1/4 times a negative 4, I get just a positive 1. 8 times a negative 1/4, well, that's a negative 2. This is called row echelon form. Now, the reason why people have you create this is because it's really easy to use what is called back substitution. I know z is a negative 2. So if I go backwards, I would have y plus z is a negative 2. That equals negative 2. So now I can easily solve for y. I just need to add 2 to each side. Negative 2 plus 2, well, that's a 0. Now I could take the z and the y and do back substitution to solve for x. X minus 4 times y is a 0, minus z is a negative 2. That has to equal 3. Well, negative 4 times 0 is 0. So it's x. If you minus a negative, you're actually adding 2 equals 3. To solve for x, I would minus 2. 3 minus 2 is 1. So x is 1, y is 0, z is negative 2. So the way that you write that is called an ordered triple. It is in parentheses, x, then y, then z. That is row echelon form using systems of equations. Then what happened in this chapter is they introduced what is called a matrix. And matrices came about because it's another way where we can solve systems of equations. You can take a system and write it in what's called an augmented matrix. So there you are just using the coefficients. So this is what the augmented matrix would look like for the top row. 1 in front of x, negative 4 in front of y, negative 1 in front of z equals 3. The middle row, 2, negative 5, 1, 0. The bottom, 3, negative 3, positive 2, negative 1. This is an augmented matrix for the system. Then what happened is they said, hey, guess what? You can actually keep the system using matrices you can solve without ever having to go back into an actual equation. And that is called Gauss-Jordan. In order to get into Gauss-Jordan form, which is where you have only zeros and ones, you need to first go into row echelon form. The rules are the same. So I need ones here and I need these to be zeros. So I would go ahead and take negative 2 times row 1, add row 2, I will get a 0. I need that 0 in the second row. Again, it's because I want a 1 here. These need to be zeros. So I'm keeping the top the same, keeping the bottom the same. If I take the top and I multiply every number by negative 2, negative 2, positive 8, positive 2, negative 6, add it to row 2, 2, negative 5, 1, 0. Whatever numbers I get, that's my new row 2. Negative 2 plus 2, that's a 0. That's what we need. 8 plus a negative 5 is 3. 2 plus 1 is 3. Negative 6 plus 0 is negative 6. Okay? Just like last time, our focus right now is on row echelon form. These values are all divisible by 3. So I'm going to go ahead and complete that row 2 by saying 1/3 of row 2 is my new row 2. So I keep the top, 1, negative 4, negative 1 equals 3. The bottom, 3, negative 3, 2 equals negative 1. I'm taking every single number in the second row and multiplying it by 1/3, which is the same as dividing by 3. 1/3 of 0 is 0. 1/3 of 3 is 1. 1/3 of 3 is 1. 1/3 of a negative 6 is negative 2. Now I'm going to go ahead and get this 0. I'm going to multiply the whole top by negative 3 because this would be a negative 3. If I add it to 3, I get a 0. So I would have negative 3 times row 1. Add it to row 3, I will get a 0 in the X location. I want that 0 in row 3. So I'm keeping the top the same. I'm keeping the middle the same because right now they're good for row echelon form, and you have to get row echelon form first. Take the top times negative 3. Negative 3, positive 12, positive 3, negative 9. Add it to the bottom. 3, negative 3, 2, negative 1. Negative 3 plus 3 is 0. 12 plus a negative 3 is 9. 3 plus 2 is 5. Negative 9 and a negative 1 is negative 10. We are not at row echelon form yet because I need this to be a 1. Well, if I multiply the second row by negative 9, this would be a negative 9. If I add it to 9, I'll get a 0. So that's what we're going to do. So I'm taking negative 9 times row 2. Then if I add it to row 3, I'll get the 0 in the Y location, and I need that 0 in row 3. So I'm keeping the top the same. I'm keeping the middle the same. Now I'm multiplying the middle by negative 9. Negative 9 times 0 is 0. Negative 9 times 1 is negative 9. Negative 9 times 1 is negative 9. Negative 9 times negative 2 is 18. Add it to the original, or where we were at, your row 3. 0, 9, 5, negative 10. Whatever I get, that's my new row 3. 0 plus 0 is 0. Negative 9 plus 0 is 0. That's what we wanted. That was the goal here. Negative 9 plus 5 is negative 4. 18 plus a negative 10 is 8. Now to get row echelon form, this needs to be a 1. Otherwise, we're good to go because this has X, Y, Z. This has Y, Z. This just has Z. To make this a 1, for my fifth step, I need to get rid of the negative and the 4. So the way that I do that is I multiply by negative 1/4. And that is my new row 3. 1, negative 4, negative 1 equals 3. That's the top. 0, 1, 1 equals negative 2. So if I divide everything by negative 4, that will be my new row 3. Well, I get a 0, 0. Negative 4 divided by negative 4 is 1. 8 divided by negative 4 is negative 2. This is row echelon form. Now what happens with Gauss-Jordan is I need to make this a 0, this a 0, and this a 0. What I think is the easiest is go from the bottom to the top. So if I want to cancel this, I just need to make this a negative 1, then I can add it. So what I'm going to do is take negative 1 times row 3, because this would become a negative 1. If I add it to row 2, a negative 1 plus 1 would be 0. I need the 0 to be in row 2. So now I'm keeping row 1. 1, negative 4, negative 1 equals 3. The bottom is good to go. 0, 0, 1, negative 2. Take the bottom times a negative. 0, 0, negative 1, 2. Add it to row 2. 0, 1, 1, negative 2. So 0 plus 0, that's 0. 0 plus 1, that's 1. Negative 1 plus 1, that's 0. 2 plus a negative 2, that's 0. Okay, so these two rows are good to go. The top can only be 1, 0, 0. So again, notice this. If I just add them the way that they are, I'm going to have a 0 in the Z location. I need that in row 1. So for my 7th step, row 1 plus row 3, I'm adding those two rows together. I will get a 0 in the Z location. I need that in row 1. So the middle row stays. The bottom row stays. Now if I add row 1 and row 3, 1 plus 0 is 1. Negative 4 plus 1 is negative 4. Negative 1 plus 1 is 0. That's what we wanted. 1 or 3 plus a negative 2, that's a 1. Last thing, I need a 0 here. So if I take row 2, if I multiply this by 4, I would get a 4. Add it to a negative 4 and I'll get a 0. So my 8th and final step, 4 times row 2. This will be a 4. If I add it to row 1, I'll get a 0 in the Y location. I need that in row 1. So here is my Gauss-Jordan matrix. 0, 1, 0 equals 0. That is the middle. 0, 0, 1 equals negative 2. That's the bottom. I'm going to take the middle times 4. 0, 4, 0, 0. Add it to the top row. 1, negative 4, 0, 1. That's my new top row. 0 plus 1 is 1. Negative 4, positive 4 makes 0. 0 plus 0 is 0. 0 plus 1 is 1. Once you have it in Gauss-Jordan form, meaning your main diagonal, upper left to the lower right, if those are all 1s, everything else is 0s. This is your X, this is your Y, this is your Z. So your order triple is 1, 0, negative 2. Okay, then what we did later on in the chapter is we learned how to find what are called determinants. Now what a determinant is one number that can represent a square matrix. So if your matrix is a 2 by 2, a 3 by 3, a 4 by 4, you can find a determinant. If it's a 2 by 2, you multiply the upper left times the bottom right number. 6 times 3 is 18. Minus, multiply the bottom of the first column times the top of the second column. Negative 5 times 2 is negative 10. Anytime you minus a negative, you're actually adding. So 18 plus 10 is 28. That is the determinant. If you have a 3 by 3, your first step is to take the first column and rewrite it on the outside. So 2, 4, 4. Then you take the second column and you write it on the outside. Negative 1, 2, 2. What you do is now you start in the upper left and you're going to draw a line. Your line must go through 3 numbers and you're going to multiply those numbers. 2 times 2 times 1, that's 4. Plus, now you start in the middle of the top. Negative 1 times 1 is negative 1 times 4, that's a negative 4. Plus, now you start upper right. 0 times 4 times 2 is 0. That's going to make your first number. Positive 4 plus negative 4 plus 0 is 0. Now you go from the bottom corner. 4 times 2 times 0 is 0. Plus 2 times 1 times 2 is 4. Plus 1 times 4 times negative 1 is negative 4. 0 plus 4 plus negative 4 is 0. Your determinant. The first number minus the second number, 0 minus 0 is 0. If you ever are asked to find the determinant, and if you look at your main diagonal and you either have a triangle of zeros below it or above it, or sometimes even both, the way that you would find that determinant is you just multiply the numbers from the main diagonal. Because this corner is all zeros, I can take 5 times 1 times 3 times negative 2, and that's your determinant. 5 times 1 is 5. 5 times 3 is 15. 15 times negative 2 is negative 30. There's a review of determinants. 2 by 2s, 3 by 3s. These are called triangular matrices. Okay, then what we did is we looked at operations for matrices. You can add and subtract matrices as long as they have the same dimensions. So if I look, this is a 3 by 2 because I can go across horizontally 3 times, vertically twice. B is also a 1, 2, 3 by 2. Because these are both 3 by 2s, yes, I can add them. So I take -2, -1, 1, 0, 3, -4. That's the A matrix. Plus the B matrix. 0, 3, 2, 0, -4, -1. When you are adding or subtracting matrices, what you do is you just add or subtract the numbers that are in the same location. So on the top column, the first number, -2 plus 0 is -2. -1 plus 3, that's +2. Go to the second second row. 1 plus 2 is 3. 0 plus 0 is 0. Go to the bottom row. 3 plus a -4 is -1. -4 plus a -1 is -5. That is the sum. Now here they want me to take C minus A. Well, C is a 2 by 2. So this right here is undefined. It's undefined because I cannot take a 2 by 2 and minus a 3 by 2. Because the rule says you can only add or subtract if you have the same dimensions. Okay. Now this number up front, this is called a scalar. And a scalar, think of it as like distributing. That number needs to go to every single entry in that matrix. So if I have 5 times B, I'm going to take the B matrix and multiply every single number by 5. 0 times 5 is 0. 3 times 5 is 15. 2 times 5 is 10. 0 times 5 is 0. -4 times 5 is -20. -1 times 5 is -5. Minus, now they want us to take 2 times A. So again, think of it as distributing. You're going to bring a 2 into all of those entries. 2 times -2 is -4. 2 times -1 is -2. 2 times 1 is 2. 2 times 0 is 0. 2 times 3 is 6. 2 times -4 is -8. Now I can subtract them. And again, the reason why I can is because both of these are 3 by 2s. They have the same dimension. You just subtract the numbers that are in the same location. 0 minus a -4. If you minus a negative, you're actually adding. 0 plus 4 is 4. 15 minus a negative. So again, I'm adding. 15 plus 2 is 17. Middle row. 10 minus 2 is 8. 0 minus 0 is 0. Bottom row. -20 minus 6 more is a -26. -5 minus a negative. So I'm adding. -5 plus 8 is 3. So that one had what's called scalar multiplying and subtracting. Now, if you are ever asked to find the product of two matrices where you're actually multiplying them, when you write the dimensions, the middle two numbers have to match. So A is a 3 by 2. C is a 2 by 2. I can multiply these because the middle two numbers match. The outside numbers, that's the size of your solution. My solution is going to be a 3 by 2. So what I do is I'm going to go ahead and multiply. A is -2, -1, 1, 0, 3, -4. If I multiply it by C, 1, 0, 2, -1. So to find row 1, column 1, I take the top row times the first column. You multiply. -2 times 1 is -2. Plus, shift over, shift down. -1 times 2 is -2. Add those two together. -2 plus -2 is -4. Now I stay with the top row, go to the second column. -2 times 0 is 0. Plus, -1 times -1 is 1. 0 plus 1 is 1. I'm done with the top row, so now I go to the middle row. 1 times 1 is 1. Plus, 0 times 2 is 0. 1 plus 0 is 1. I go middle row, second column to get that number. 1 times 0 is 0. Plus 0 times -1 is 0. 0 plus 0 is 0. Done with the middle row. Now I go to the bottom. 3 times 1 is 3. Plus -4 times 2 is -8. 3 plus a -8 makes -5. Bottom row, second column. 3 times 0 is 0. Plus -4 times -1 is 4. 0 plus 4 is 4. There's the product. Now if I look at the next one, C times A, you have to go in this order. C is a 2 by 2. A is a 3 by 2. When I write their dimensions in the order C times A, the middle numbers do not match. So I cannot find the product. So this is said to be undefined. Last idea for chapter 7, Cramer's rule. Now what Cramer's rule is it is a method of solving systems of equations by only using determinants. First, you must find what is called your original determinant. You take your coefficients, just the numbers in front of the letters, and you form a matrix. So this would be 2, -1, 3, 2. You find the determinant. It's a 2 by 2. 2 times 2 is 4, minus 3 times a -1 is -3. If I'm minusing a negative, we're actually adding. 4 plus 3 is 7. That's your original determinant. Now to solve for x. What I do is I recreate the top matrix. I'm solving for x, so the solutions go in the x column. So -10, -1 go here. In front of the y's, I keep those values the same, -1 and 2. This is because you're solving for x, so you keep the y's the same. You change whatever variable you're solving for. That column, you go ahead and fill in the solutions. I find the determinant, then divide by the original. -10 times 2 is -20, minus -1 times -1 is +1. -20 minus 1 is a -21, divided by the original determinant, which is 7, x equals -3. Now to solve for y, because I'm solving for y, this time the solutions go in the y column. The x's stay, 2 and 3. I need to find the determinant of the top and divide it by the original determinant. 2 times -1 is -2, minus 3 times -10 is -30. If I'm minusing a negative, I'm actually adding, so it's -2 plus 30. That gives me a 28. 28 divided by 7 is 4. So my solution is -3, +4, and there is a really solid review for Chapter 7. Good luck on your test, guys.